right? So let us study more about functional dependency. So these are the things, right? In functional dependency, single valued functional dependency, fully functional dependency. So we have studied a fully functional dependency in today's class, right? So yeah, relation is said to be in a second normal form if it meets the requirements of full functional dependency, right? So all the non-prime attributes in a relation should be fully functionally dependent on the prime attribute. Similarly, we also studied about transitive functional dependency. If X determines A and A determines B, then there exists a dependency between X and B, and it should not be there in the case of third normal form, right? So transitive dependency should not exist between the attributes in a relation, and we studied how to eliminate transitive functional dependency, right? So yeah, in third normal form, we have discussed how any non-prime attribute should not be transitively dependent on the prime attribute, right? So we'll study something, we'll explore something more about trivial functional dependency, non-trivial functional dependency, semi-non-trivial functional dependency, and so on, right? So what do you mean by functional dependency? So you would have done some already done, we have done some examples with functional dependency. Anyway, functional dependency is the relationship between the attributes. So suppose that given one attribute, we can obtain the value of another attribute. We say that they are functionally dependent. So for example, if you know the customer account number, right, account number of a customer in a bank, you will be able to get the customer's address, balance details, and so on. So we say that the customer's name, account balance, they are functionally dependent on the attribute account number, right? So in general terms, the attributes Y is functionally dependent on attribute X. So it means that we have X determines Y. So here account number is the variable X. So using the account number, you'll be able to determine the name of the customer, balance amount of the particular account, right? And you'll be able to determine the address or location of the customer. So X functionally determines Y, right? X arrow Y means X functionally determines Y. So the left hand side of the attributes determines the values of the attributes on the right hand side, right? So attributes on the left hand side are known as determinants. So for example, in this case, a simple relation, you have price and number of items, and total price is going to be item price into number of items. So we say that there exists functional dependency between item price, number of items, and the total price, right? So total price is dependent on item price and the number of items in that relation. So we'll study about single valued functional dependency, fully functional dependency, partial functional dependency, and so on. So single valued functional dependency, right? So the information in a relation is either a single valued or multi-valued. So for example, the name of the person is going to be an example for single valued fact, or his date of birth is an example for a single value fact. So when A is the primary key of an entity and B is some single valued attribute of the entity, then A determines B must always holds good, right? So you know the roll number. So roll number can determine the date of birth of the student. So where B is going to be a single valued fact, right? So this is known as a single value dependency, right? So fully functional dependency. So we'll study the definition for fully functional dependency. So a functional dependency P determines Q is a fully functional dependency if removal of any attribute A from P means that the dependency does not holds anymore, right? So you have a functional dependency between two attributes, right? P and Q. So P is a determinant, P determines Q. So Q is fully determinant on P if the removal of any attribute A from P means that the dependency does not holds anymore. So for example, if AD determines C is a fully functional dependency, then we cannot remove either A or D. So that is C is fully functionally dependent on A and D, right? So the previous example was example for fully functional dependency. So how will you determine the total price? So total price is determined by the number of items and item price. So if you are going to remove item price or number of items, you will not be able to determine the total price, right? So we say that the left hand side, the determinants are fully the right hand side is fully dependent on the left hand side, right? So in the case of fully functional dependency, if AD determines C, then we cannot remove either A or D, right? So that is C is fully functionally dependent on AD. Whereas if you are able to remove A or D, then it is not fully functional dependency. It's partial functional dependency, right? So again, we have an example for partial functional dependency, right? So a functional dependency in which one or more non-key attributes are fully or non-key attributes are functionally dependent on a part of the primary key is called partial functional dependency, right? So for example, consider a relation R with attributes A, B, C, D, and E having the functional dependencies AB determines C, D, E, where AB is the primary key. However, there exists some partial dependencies such as A can determine C, A can determine D, A can determine E, or B can determine C, B determines D, B can determine E. So they are known as partial functional dependency, right? So for example, consider a student data which contains both Aadhaar number as well as roll number. So you'll be able to determine name of the student using both Aadhaar ID as well as roll number. However, it is also possible to determine the name of a particular student by using Aadhaar ID, right? So there exists some partial dependency. So initially we say that Aadhaar ID and roll number will be able to retrieve all the details of the student. However, using the Aadhaar ID itself, I will be able to retrieve the name of the student, address of the student, right? Contact number of the student and so on. Then it means that there exists some partial dependency between the attributes in a relation, right? So there exists some partial dependency between the non-prime attribute, the student name, and the so there exists some partial dependency between the student name and the prime attribute Aadhaar ID in the relation. We say that it's going to be partial functional dependency, right? So so given a relation or with attributes A, B, C, then there exists a dependency in this format. A determines B and B determines C is called transitive dependency since A determines C is implied, right? So there exists a set of elements in a relation such that A determines B and B determines C. Then you can infer A determines C is implied, and this is known as transitive dependency. And as per the third normal form, there should not be any transitive dependency between the elements in a there should not be any transitive dependency between the non-prime attributes and the prime attributes in a relation, right? So let us study something more about trivial, non-trivial, and completely non-trivial functional dependency. So a trivial functional dependency is one where the right hand side is a subset of left hand side, right? So you have determinant in the left hand side. So the right hand side is going to be a subset of the determinant, right? ABC determines BC, right? So it's known as a trivial functional dependency. A dependency is said to be a trivial functional dependency if the right hand side is a subset of left hand side, right? So example of trivial functional dependencies: ABC determines BC, and then we have non-trivial or semi-non-trivial functional dependency, where at least one of the right hand side attributes are not part of the left hand side, right? So semi non-trivial functional dependency means at least one or few of the right hand side attributes are not part of the left hand side relation. So for example, A, B, C determines C, D, E, right? So here the attributes D and E are not part of the left hand side determinants. So it's going to be semi non-trivial functional dependency. So you have only one attribute common in both left hand side and right hand side. A, B, C determines C, D, E. So D and E are the attributes in the right hand side. They are that are not part of the left hand side attributes. So we say that it's a semi non-trivial functional dependency. And finally, we have a completely non-trivial functional dependency if none of the right hand side attributes are part of the left hand side attributes, right? So for example, in this case, A, B, C determines D, E, F, right? So here none of the right hand side attributes are part of the left hand side attributes. So we say that it's going to be a completely non-trivial functional dependency, right? So this is how we define a trivial functional dependency, semi-trivial functional dependency, and completely non-trivial functional dependency, right? So trivial functional dependency means the right hand side is a subset of left hand side, right? So the right hand side is a subset of determinant that is present in the left hand side. We say that it's a trivial functional dependency. Semi-trivial functional dependency means at least a few of the attributes in the right hand side are not part of the left hand side, and we say that it's going to be a semi-trivial functional dependency, semi non-trivial functional dependency. And completely non-trivial functional dependency means the right hand side attributes are not part of the left hand side attributes. We say that it's completely non-trivial functional dependency, right? So once we have this, we'll discuss about the inference rules for functional dependency. So you given some rules, you'll be able to create some additional rules by using this Armstrong inference rule, right? So let S be a set of the functional dependencies that are specified on the relation schema R. Numerous other dependency can be inferred or deduced from the functional dependency in S. So for example, you have a set of functional dependencies, set S equal to A determines B, B determines C. So we can infer the following functional dependency like A determines C, right? So in order to infer some additional rules or additional functional dependencies, we go for this Armstrong inference rule. So we'll study three properties of Armstrong inference rule: reflexivity property, augmentation property, and transitivity property, right? Uh, so in the case of reflexivity property, if B is a subset of A, then A determines B holds good. It's known as reflexivity property, right? So you have a set of attributes A, and B is a subset of A, right? So if B is a subset of A, then it means that A determines B can be proved. So it's known as reflexivity property. So in the case of augmentation property, if A determines B holds good, then AC determines BC also holds good. So if you are going to augment some attributes in the left hand side and the same attribute in the right hand side, it holds good. And in the case of transitive property, if A determines B holds good and B determines C holds good, then A determines C is also, it also holds good in that relation. So it is known as transitivity property. right? So using this Armstrong inference rule, you'll be able to infer some additional rules in a relation. You can infer some additional functional dependencies also in a relation. So A determines B, where B is a subset of A. It's known as reflexivity. AC determines BC. If A determines B holds good, then AC determines BC holds good. It's known as augmentation. And in the case of transitivity, if A determines B holds good and B determines C holds good, then A determines C also holds good, right? So this is known as a transitivity rule, right? So that's it for today's class. So any questions from today's class materials?
No, sir.
Right.
No,
So,
sir.
so we have discussed about first normal form, second normal form, 3NF, BCNF, and we also studied something about functional dependency, where we have discussed about trivial functional dependency, completely non-trivial functional dependency, semi non-trivial functional dependency, and we extended it to Armstrong rule of inference. So given some functional dependencies, you will be able to add some more FDs using this Armstrong rule of inference, right? So that's it for today's class. So thank you for your participation. So it looks like only 54 students they attend my class. We have a strength is around 74 students. So I'm downloading the attendance sheet every day and I'm keeping a note of it. The thing is that students are expected to sincere attend the class.
Yes, sir. Few students have OTs and stuff going on, sir. So that's why maybe.
Right. So everything is online, right? So they have to attend the class. So last year we get around 100% attendance, but it looks like this semester the attendance is falling drastically. So I would like everyone to attend the class.
Yes, sir. We'll put it on the group.
Okay, so thank you. We'll meet during the next class. So next class I will teach you something about a lab. So we'll study about working with Python and MySQL, how to work with the backend database and the front-end programming language for our lab.
Thank you, sir.